Hello everyone, Nadezhda here, and today we are going to learn how to set up the coordinates of our Revit file using the CAD survey file. This is the file that I'll be using, and I have the blank Revit file here, and I'm going to now link that file and then set up the Revit file to be in the same coordinates. Some things that we should keep in mind before linking the file are units. I have started this blank default file and I can see that the length is in millimeters. And this file is, I type UN on my keyboard and click enter, and this takes us in the units options in AutoCAD, and I can see that this file is unitless. This is something that you're going to be encountering a lot with the survey files. Basically, they will be drawn in one units and set up in other units. This is basically because sometimes people draw without paying attention to the settings, but it doesn't matter. What matters to you is actually which units are used to draw this file. That means basically we have to just check out some distance and we'll know the units. For example, I have a pathway here and I can go to the distance tool and check out what's the width of this path. And I can see it's 1.7, that means it's basically meters. So that means everything we do now will be done in meters, and this is actually one of the most important steps to you, because if you mess up here, you are not going to be able to set up your file properly. You have to be very mindful of the units of your CAD file. And now that I know that my AutoCAD file is in meters, I go back to the units and I see that my length is in millimeters like we said, and I'm going to change this to meters. It is not a necessary step, but I have found it to be the easiest when we have two files that are in the same units. I have no additional steps of like converting any units and anything, just have two files that are in meters, and once I am done with setting up the coordinates, I will just turn back my file into millimeters or centimeters, whatever I use to work in this file. So I go back to meters. I usually turn this to 2 decimal places as well, and I click OK once again, and now I'm ready to insert my CAD file. I go to insert and I go to link CAD. It is best to link CAD, not to import it, because that way it is going to be a lot easier for you to work with it. So I click link CAD, I select file, and before we click open, there are a few things that we should keep in mind of. We have layers, and here I'm just going to choose all layers. But if your file has some redundant layers, if there is something that you do not wish to import, you can also click specify to actually specify which layers you want to insert. You can also click visible to just insert visible layers. You can also choose what you want to do with colors, whether you want to preserve the colors or turn it to black and white. In this case, I keep all of this by default, and this is the most important setting to you, and that is the import units. I usually don't use auto detect, because with auto detect you basically have to have a file that is perfect. That means it is drawn in one unit and also set up in those same units, and this file obviously does not fall into that category. So here I am actually going to choose meters, because like I said, this file is drawn in meters. That means I choose meters here. So that is why in the beginning we have been measuring our path, and that is to know what option to use here. So whatever unit was used to draw a file is the unit you choose here. This is the step I have to mention a couple of times, because this is actually where most people have trouble with. They will insert in the wrong units, and then the file will be all wrong, or rather too small or too large, and obviously in that case the coordinates will not be right either. So I choose meters here, and as for positioning, it doesn't matter now, because right now our file is not set up, but the goal of this lesson is actually to get our file to be in the shared coordinates. What does that mean? That means basically every time when you have the georeferenced AutoCAD file, you will be able to use this by shared coordinates option. And that means that your file will be instantly set up right once we set up our units. So for now you can use either center to center or origin to internal origin. It doesn't matter for now. And once we have done all that, we can also choose which level, and for now we have only this one default level, so we obviously choose that. And that is it for now. We click open. We wait a little bit. And we have our file now. It is important to actually check whether your file is right, and you do that by actually going to modify and measure between two references and then check whether this path is in the appropriate units. And since I turned my file to meters, I can see that this is, for example, 3.4, and that means it's correct because the path is 3.4 meters wide here. Of course, if in this step we see that the units don't match, then it's time to actually go back a few steps and check out where we missed. I will just turn off the scope box here so I can see my entire plan. I go to the scope box option, choose none, and I also turn off the crop view option. The reason why I did this is obviously because my file is bigger than the scope box, so I will also remove these scope boxes because I do not need them right now. So we have linked our file, and the next step is actually georeferencing it. When I say georeference, I mean I take the coordinates and the heights of the CAD file and set up my Revit file coordinates and heights to be the same as this CAD file. So the first step I do is I go to the manage option, and here I have the project location options, and these are all actually for setting up our coordinates. I click on the coordinates option and I click on the acquire coordinates. What this does is actually take automatically the coordinates from the CAD file and transport them to Revit. I click on my CAD file and I should be able to get this message that says that basically coordinates are acquired from this file. I click close, and now I know that my coordinates are set up. But I do need to test that first to be sure that that is the right thing. And what I do is I go back to my CAD file and I just choose one spot. For example, I find this one to be easiest one and I click on the ID. What this does is give us the coordinates of the spot. I click here and I can see these coordinates. I will just choose the snipping tool and I will snip this part because I want to remember these and I can't remember. So I go back to AutoCAD file and now we have this snip of the file that we are supposed to remember. This is where turning our file to meters helps, because otherwise these units would be turned to millimeters and we don't want that because it just confuses us. I go now into my Revit file and I go to annotate tool and I go to spot coordinate. This is pretty much doing the same thing as the AutoCAD ID option. I basically just set this coordinate here and I just check whether these coordinates and these numbers are the same. So we have X, which is 657 and something else. We can see that it is the same number, and the same goes with the I, which is actually north. Here we can see that it is exactly the same number. So that means that our coordinates are correct, and this is something you should always do with the AutoCAD files. You should always check whether these coordinates are right, because you don't want to actually set up the file, start working in it, and somewhere along in the project to just realize that the coordinates are not right. Once you are done with this step, you always go to the ID tool in AutoCAD and spot coordinates tool in Revit and check whether your coordinates are exactly the same number. These numbers should match exactly if our files are correct. I turn this off now, I can delete these coordinates, and now that we know that our file is correct, the next step is setting up the true north and project north. What does this mean? Basically, the true north is the position of the file that we see in the site plan. This is actually the true north. This is the correct position of the true north, and that is the position of your file, of your plot and building in correlation to the world, basically. And this is the perfect setup for true north, but we actually have the project north, and project north is the setting, the placement of the building that we use in the floor plans. Basically, you do not wish to have this slanted plan in the floor plan. You actually want your plan to be with the straight lines. And when we are setting the project north in a project, we basically use one of the sides of the plot. It is something that we set up right in the beginning, and that is basically the orientation of our floor plans and our building. And I'm just going to use this purple line to be the orientation of my project north. And this is something you usually do when you begin working on your project, like right in the concept stage. Basically, you choose some road or some side and set up your building according to that. I am in this case going to be using this purple line, and I'm going to set up my building and my project north to be parallel to this line. I also have to note is that this does not actually modify your coordinates in any way. It is simply positioning your floor plans to be in the orientation where you can model comfortably, because if we had to model in this orientation, obviously it would not be good, because we would have to slant all of our walls, and we don't want that, obviously. So first we have to set up the true north and project north. And what we do is we go back to the manage tab and we go back to the project location tools, and in the position we find the rotate project north option. We now use this align selected line or plane option to simply align with some side of our plot. And I will just click on this purple line, and now our project north is successfully rotated. We have to check this message, of course, to see if it was successful. We don't want to get any error here. So we click OK, and what we get now is we get the plan which is in the project north. It is completely aligned with this one line. That means whenever we are modeling our plans, we will have this orientation of project north set up here. And when we are modeling the site plan, when we want to create the site plan for this project, I will simply turn that plan to be true north. This will, as you can see, change our positioning back to the true north, back to the original orientation, and this is something that you will be using for site plans and similar drawings. But when we are creating the actual floor plans, we will simply turn back to the project north, and we will have the straight lines for our buildings. I also want to note a few things before we go back to the setting up of height. And that is, when you are exporting your site plan, you do want it to be in the correct coordinates. And when you do that, you go to File, Export CAD Formats. And what you have to keep in mind is once you go to these settings and go to the units and coordinates, you have two options for exporting. First is the shared coordinates, and the second is internal origin. So if you export this plan with the internal origin options, your coordinates will not be correct. You do want to turn this to shared coordinates if you want some correct positioning, if you want the file that will be easily linkable with other files. So you must keep in mind to turn this if you want the georeferenced file. Of course, sometimes that does not matter to you. If you want to, for example, export some work in progress files or something, you simply do not care. And in that case, obviously, you can leave it as internal origin. But if it's something that is some sort of the submission that is important, where you have to have the correct coordinates, you must make sure to change this setting. And what is also important, and that is the fact that you actually don't get the correct coordinates when you export these plans from sheets. Basically, it is something that we were all hoping that will be updated by Autodesk at some point, where we can actually export sheets in the correct coordinates, but it has still not happened. So if you want your plan to have the correct coordinates once you export, you must export it from the view, not from the sheet, and then Basically, if you need the title block in that plan, in that view, you add it in the AutoCAD additionally, which is a little bit of bother, obviously, but until that is sorted out, you basically have to export your georeferenced plans from the view if you want them to have the correct coordinates. I will turn back my file to the Project North. And now, before actually going to setting up our project heights, I will first do one more exercise. And I know that this is a lot of checking up to do, but I do want to check up my files a few times to know that my coordinates are correct. Basically, I do want to check everything that I can check, because I don't want to find myself in the position where I'm working on a project and then after I have modeled the entire building, I realize that my coordinates are not correct. So I do few exercises of checking up if my coordinates are correct. Now that I have turned my orientation to Project North, I want to link this same file again in this model using the shared coordinates option. So I go to Insert, Link CAD, and before that what I do is I use this same file and I copy it again, just using the different name, because Revit will not let me insert the file with the same name again. But basically I just want to copy it and then rename it, and then I can link it again. And what I do now is I make sure that import units are meters, and I actually use by shared coordinates option here, because now that we have our file set up, this option should work perfectly when we are basically linking the files of our consultants and their models. Basically, we should not be doing any manual settings here, but actually simply using by shared coordinates and then being able to simply link in place perfectly by this one option. And now I click open. And I can see now that my file is actually in the same place. This first file that we used for linking actually has all of these additional lines hidden, so we have easier time, we don't have any messy lines, but this other file didn't have these lines hidden, and that way we can see that it actually fell right into place. When I select this upper file and I go to the hide element, I can actually see that the clean plot lines file is actually visible below in the exact spot where this file is. I just go to the reset temporary files and I will simply remove this upper file by going to manage and simply clicking on it and clicking the remove. And that way you should also do the checkups with your own file to make sure that everything falls into place correctly before you start working in the building, because you do not wish to send someone the files with the wrong coordinates, obviously. So like I said, I do recommend doing these checkups several times, just so we know we have set this up correctly, because this is obviously the important part of the project. It is setting up the files, and you don't want yourself nor your team to work in the incorrectly positioned files. You do want to check this several times. Now let's go back to the lesson. And now the next step is actually setting up the heights of our file, because obviously we have set up the horizontal coordinates, but our file is still in the 0. So I create one section or use some existing one, it doesn't matter. I go to view, and I can see now that I have the L1 and L2, which are obviously the generic levels. And I do want to change the height of my project, obviously, to be in the true height of this file. This is usually done by choosing some coordinate in some correlation to the road. For example, if this purple line is where our road is and we enter the building this way, we do want to set up one of these coordinates to be basically the 0 of our buildings. Of course, what I am explaining here is some hypothetical situation. Obviously, for each building, this is going to be different, and you will have your own way of setting up the 0 of your building. And I'm just going to choose some of these coordinates, for example, this 333.29 height. I go back to my section. And this step is actually kind of important because by default in sections we actually see the project height. This is not the true height, this is not the absolute height, but actually the project height. And before we start doing this, what we first want to do is turn our levels from showing the project height to turning the true heights. I go to Edit Type. And here I can see that the elevation base for our levels is project base point, and I want to turn it to survey point. This will give us the actual true height of this project. I click OK, and it is still 0 because it is not set up. And what I do next is I go back to this project location tools and I choose the specify coordinates at point option. I click on my level. And here I simply insert the height of the 333.29. What I first have to note is to also mind the units because I have turned my file back to meters, so I can simply insert the exact height that I saw on that plan. But if your files are, for example, in centimeters, you have to insert this number in centimeters, basically convert it to the units you are using in the model. As I said, these are basically the reason why I convert my files in this beginning, because I don't want to forget that. I usually end up forgetting this, and then I just import the unit that I see, and that is obviously going to be wrong. So make sure that your units are right. Be very mindful of the units in this entire exercise. So once I have done that, I click OK. And now I can see that my levels are changed and they are now showing the exact survey height of this file. I can now go back to the edit type and change it back to project base point, because when you have the sections you actually want to show the project height, but you also want to make sure that your project is in the correct heights. Basically, when you are later adding the elevations to your project, you can either add this target project, which is 0, but once you click on it and then go to the edit type and change it to showing the survey point instead of project base point, it will be showing your exact heights. And now that most of the work is done, there are only a few more things that we should check. And I will go back to my plan and I will go to Visibility Graphics Override or Template, and I will go to the Site option and turn on my survey point and project base point. I will do the zoom extends by clicking the mouse pen twice, and what I can see is that my survey point is very far away, and that is because in AutoCAD my 0 point is actually very far away, exactly where it is in Revit. I will just go to the line tool and I will click 0, 0, 0. And as you can see, this is where it is. It is very far away from my building, and that is basically the 0 of the world coordinates. I will just escape this tool and go back to my plan and go back to Revit. While these coordinates right now are correct, and this is not actually the necessary step, the file will work even if you leave the survey point here. You do not want it to be this far away from your drawing. If you have the survey point visible in your drawings, you do not want to have this large of extents. You can either turn it off or you can actually set it to be somewhere on your drawing. What I can do now is select it, and what you must do in this case is click on this little clip here. If you don't click on your clip, you will change your coordinates, your entire model coordinates, and we don't want that. We just want to change the physical position of our survey point. So I will first unclip it and then I will go to the move tool. I will grab my survey point and I will bring it somewhere on my project where it actually makes sense. For example, let's just put it somewhere in the edge of the plot line. And that positioned my survey point here. I will also change the elevation. I will make it 333.29, just like I did in my section, and then I will clip it back again. I go back to section and I can see that none of the coordinates changed, and also none of the coordinates from this file also changed. As for the project base point, it is the point that defines our project. Usually architects put it somewhere either in the intersection of some grids or on some specific place on our plot line, like where we put the survey point. I will just draft some imaginary grid lines and I will put it in the intersection of these lines. Let's just say these are my grid lines, and then I will grab the project base point and I will simply move it into this intersection. So this is now my project base point. This is actually the point from which I measure some grids, some important items of my project. Also, what you should do before continuing any work is you should select both of these points and you should pin them. We do this because we don't want to accidentally move them, because these elements are obviously very important, and if you by accident grab them and move them, you can cause a lot of the problems on your project, so you should better pin them and never unpin them. And what you should also do is hide them. You should go back to visibility, graphics overrides, go back to the site option, and then hide these, because unless you are setting up the coordinates, there is no need for these to be visible. Once you're done with everything, I recommend you doing one final checkup, and that is actually going to spot coordinate tool and putting it somewhere where you know the coordinates. And I have the print screen of the previous coordinates of this place from the AutoCAD, and let's just do one final checkup to see if our coordinates are correct. And this is what we get. These numbers match perfectly, and we have basically finished setting up our files. We now know the coordinates are correct. We have the project north, we have the true north, and we have also set up our survey point and our project base points. And this is it about this lesson. We have learned how to set up our files correctly, and now we can begin modeling. If you like this lesson and my other lessons, check out my full architectural Revit course, where I teach this and many other topics, which is actually modeling in Revit in the context of architecture. I give out many tips and tricks about how to do this properly, and also about how to work independently or in teams. And there are actually 100 lessons and many exercises that help you master Revit very quickly and very correctly. It gives you perfect basis for actually understanding Revit in the terms of architecture and actually later on working in the field in Revit. Of course, if you had trouble with any steps, comment below and I will answer you. I answer most of the comments that my students leave in the comments, so feel free to ask, and thank you for watching, and see you in the next video. Bye! If you want to learn Revit like a pro, take a look at my architectural course through the link below. You will learn how to develop the project from concept to final design using Autodesk Revit. It is ideal for beginners, but valuable for anyone looking to build a solid foundation. By the end, you'll know how to take a design from concept to detailed documentation with confidence and clarity. You will gain a solid Revit workflow you can actually use independently or in work in larger teams in architectural studios. With almost 100 structured video lessons, it is designed to help beginners master Revit step by step. To support your progress, I've included assignments with each lesson, plus the opportunity to ask questions and receive guidance directly from me whenever you need it. This way, you're not just watching tutorials, you're actively learning, practicing, and improving every step of the way. Thank you for watching, and see you in the next video.